the simplest hydrocarbon with a double bond is ethene. A double bond right here. The diagram shows the hybrid orbitals formed by the carbon atoms and the carbon-carbon double bond in an ethylene molecule. Question A. Identify the atomic orbitals. You see those two? That's atomic orbitals. But specifically A and B, okay? So involved in the formation of the carbon-carbon double bond after the reaction, of course, that's carbon-carbon double bond right there. So first, the orbitals labeled with A, okay, identify the A atomic orbitals. So what does it mean? It means, what kind of atomic orbitals of carbon are this one and this one. Each carbon atom, that's one carbon atom, that's another one. So each carbon atom has 6 electrons. Among the 6, there are 4 of those. These 4, they are the valence electron. All right. So, and now please recall the shape of s orbital. They are spherical. All right. So s orbitals, they shaped like spherical. All right. And the p orbitals, the shape, 2 lobes. Okay. Depending on the 3D orientation, can be that way, can be that way, can be that way. All right. So now let's take a look. A, that's 2 lobes. 2 lobes. That's not s. Now the valence electron coming from 2s, because if it were from there, that would be a circle. Seeing here, or spherical. So obviously, that's P from the 2p orbitals. So therefore, orbitals labeled A in the carbon atoms, that should be p orbitals. So the answer for this one is p orbitals. Okay. Yeah, now let's take a look at the orbitals labeled with B. Obviously, you see the B is 1, 2, 3 for each carbon atom. So had 3 B orbitals. This one, same thing, 3 of the B-type orbitals. In order to identify the type of the B orbitals, so let's take another look at a molecule. I draw the structure here, it's easier to see. Let's count the number of electron groups for each carbon. All right, so that's 1, 2, 3. Remember the double bond in this case count just as 1 unit. So then that's 3 electron domains, which means that should be trigonal planar, or the hybridization should be sp2 for each of this carbon atom. All right, so sp2 hybridization. Therefore, the orbitals labeled B, they are sp2 hybrid orbitals. Now, question B. Identify the bonds C and D formed by the interaction of the hybridized orbitals. First, the bond label C is what kind of bond? Formed by 2 or which two of the followings? Okay. First, let's take a look at the bond labeled C. You see that's two blocks. One block below the axis of the nuclei of the two carbon atoms, and then another one is above. Okay, so that one also labeled as C. Okay, so then from this kind of depiction, we know this has to be a pi bond. Therefore, C is the pi bond and formed from which atomic orbitals? Actually from the orbitals labeled A. You could not see here, but it's labeled with A. Is that right? So the two 2p orbitals, okay, side by side or shoulder to shoulder approach to each other, okay, and then you will have one cloud above, another one below the nuclei axis. So that's the p bond, and then the pi bond, and then should be use two of the p orbitals. Now the next one, the bond labeled D, is okay, D, you see, that's along the axis of the nuclei. We already learned then that has to be a sigma bond. So therefore the sigma bond. And then if it's sigma bond, it cannot be formed by those two vertical p orbitals anymore, has to be the b orbitals. Let's say these two, they approach. When they approach to each other, so that form the sigma bond. So therefore, that should be a hybridized orbitals, sp2 hybridized orbitals, just like what we draw a while ago. You see, so yeah, that's sp2, and then that's the, you see. So those two are used to form this single bond, and then these two are used to form carbon hydrogen. So carbon hydrogen, just like this one, carbon hydrogen, carbon hydrogen, carbon hydrogen. So that's two of those orbitals, sp2 hybridized orbital, and then this one combined with that one form this sigma bond right here. Okay.